First of all, you will need to select what is your number of k, and it will classify those points according to the number you specify. And this is how it works. Let's say we want to separate it into 3 points. Or let's say we have 3 groups. Maybe red, this is red, this is maybe blue, we have 2 different groups, say red, say yellow, maybe yellow, say probably blue, blue. So how it works is that when you put a new point and you want to classify it as either of these 3 colors, now visually look at it now. Should this be, let me make something very simple. Look at it now. Should it be red? Should it be yellow? Should it be blue?
It's in between red and blue. It should be.
See it here. And this is red here. This is blue here. This is yellow.
It should be red.
It's red. Why do you say so?
Very close to red.
It's very close to red. How do you know it's very close to red? Subconsciously, your eye has measured the distance.
Yeah.
And say this one is smaller compared to this. This one is smaller. From here to here is between red and the point. Different is closer or lesser than between the point and blue. That's what KNN does.
Okay.
So when a new point comes, that's the way it generalizes on new data. What it will do is that it will calculate the distance. Calculate the distance between that point and the other clusters you have there, or the other groups you have there. So they call it K nearest neighbors.
Okay.
Calculate the distance between the point and the nearest neighbors. So that K now is the number of neighbors. So let's say you have 3 neighbors now on the line. So this is how it works. So at the end of the day, by the time you calculate the distance between this one and this one, maybe after calculating the distance between the point and red, you have 2. And calculate the distance between the point and blue, you have 4. Calculate the distance between this point and yellow, it has 8. To go for the lesser one, which is 2. So it looks for the minimum of the distance. Let's say x minus xi square. And now this leads me to this. Now there are different algorithms. There are different distance algorithms used. I'll mention 2 or 3. You have the Euclidean algorithm. Euclidean. That is the one you are familiar with. You know, remember in straight line geometry, distance between 2 points. Where you say x2 minus x1 square plus y2 minus y1 square. Where it's, so what it does here is that it checks the distance along both the x-axis and y-axis, because you know this point is in the xy plane. It's between x and y. So to check the distance along y, x, distance along y, square it, add it over and square it. That's Euclidean. Then there are other ones. There is Manhattan. We will not go into the details for that. And there's the Hamming. So there are different algorithms. So normally, if you are to use this KNN now, you already have the functions defined. If say you are using Python, or you have the functions defined. When you say, okay, for my distance algorithm, I want to use Manhattan, I want to use Euclidean, I want to use Hamming. So that is the KNN. That's the KNN.
Like KNN, for example, you know that it's possible, assuming that when they classify, either someone have bought is it C or B, then that student score around 60.
To 60 back.
Yeah, 60. That one is just classifying as B.
That's you, but because you already know it's closer.
Yeah, very close.
But if it's KNN, it will calculate the distance and say, okay, maybe let's say we are using a geometric function that just subtracts. So when you say 56 minus 50 is 6, 60 minus 56 is 4. So which one is lesser? 4. So that means this will be classified close to this timber.
Supposed to be
Close to, which one is 60?
60.
Or can you repeat the question? Let me get.
Assume that there's a point
Mm.
at 56.
Mm.
Yeah, I want to classify it. Is this C or B?
And C is what?
And C is 50.
And B is 60.
C is 50, C is 60.
Is it C? C? I think C is 60. C is 50 while B is 60.
Yes. C is 50.
B is 60.
Is 60.
So in that case, now which one is closer? By the time you calculate the distance, you see that it's closer to B, which is 60.
Yeah, the middle point is around
It's 55.
55.
So
The shift was.
so it's closer to B. So when you calculate distance, you get 4. You say, okay, 4 is closer than 6. So you apportion it to B. So that means in a way you can also use it to estimate, approximate. KNN can use an approximation.